So this is another great question, and I thought this would be also one that's a little bit better served by taking a quick video explanation of this. So I've got two examples, one that's got growth, one that's got decay, so we can look at the two different types of situations that we can have. So we're trying to find an exponential function that fits this table of values. So the exponential functions that we have are going to be y equals a times b to the x. So in this, b is our base, and a here actually is always going to be the y value of the y-intercept. So in this table, a is always going to be what we get for the y value when x is 0. So right here is our y-intercept. And that's because when you take and make your x value 0, b to the 0 power is 1, so it doesn't matter what your base is. When your x value is 0, your output's a. So our a in this case we know is 36. So now we just need to figure out what b is. So b, how we figure that out is we want to look at what's happening to the y values as our x values increase by 1. So in our table, our x values are increasing by 1 with each step, so that's perfect. That's what we want. And what I see here is that the y values are getting smaller as our x values are getting bigger. So what we can do is take that large number, 216, and divide it by the next number, which is 36, and we get 6. So what's happening at each step is that previous value, so here in this case that 36, it's getting divided by 6, and we get 6. Here in the next step, this 6, it's getting divided by 6, and we get 1. So dividing by 6, let me write it with ones that are not 6 there. So 36 divided by 6, that's the same as multiplying by 1/6. And so what we're multiplying by here to get our next y value, that's our base. So here is our base. So we get y is equal to 36 because that's our y-intercept, and then our base is 1/6 to the x. Now what's nice about this is you can absolutely check all of your answers really easily with this, because we can take some of these x values, plug them in, and make sure we get the right y values. So I can grab my calculator and do 36 times 1/6 to the -1. Now you do want to be careful typing this into your calculator. You want to put parentheses around that 1/6. You also probably want to put parentheses around your exponent of -1. So I would type it in like this. I would hit there my multiplication, and then I'd have a 1/6 in parentheses, and then my caret button, and then I'd have a -1. And so, what's happening mathematically with that -1 power is it's flipping over a fraction, multiplying it by 6, and we get 216. So when our input was 1, our output's 216. You can also check maybe by plugging in 2 for x. So we get 1/6 squared. And so this is 36 times 1 over 36, which is 1. So we get an output of 1. So you can always plug in those x and y values that are in the table to make sure that the equation that you get is correct. So sorry that my work is kind of all over the place on this, so if you can kind of follow that. But let's take a look at another one here, because we're looking for the same thing. We've got that we want to make this exponential function here, and our base, and b is our base, and that a is the y-intercept. So our y-intercept, we're looking on our table to when x is 0. The y-intercept is 1/4. So what we know about our equation right now is that we have its y equals 1/4 times b to the x. We need to figure out what that b is. So again, this table here, the y values are increasing by 1 as we go. And if we look at what's happening to, or the x values are increasing by 1, hopefully I said x values, and then the y values here, they're getting bigger as we go, right? We can see it right here. We're going from 2 to 16. So I'm going to see what I had to multiply 2 by to get 16, and it was 8. So I'm thinking what happens is that we have 32 times 8, which that is going to be 8/32. That's a fourth. And then we took that 1/4, multiplied it by 8. You get 8/4, which is 2. Sure, sure. And everything is working. And then we have 2 times 8 is 16. All right, so each time we're taking the previous y value and multiplying it by 8. So that's telling us our base is 8. And so up here it was dividing, but we had to write it as multiplication to figure out what our base is. So that's what we want to do with an exponential function. What's happening is your y values each time are getting multiplied by that base. So that's why we, try to figure out that multiplication either with division or, how we were doing up here. We were dividing, or here we also divided. We were trying to figure out what we were multiplying each time by. And so our overall equation is y is equal to 1/4, 8 to the x. And again, we can plug in some of these x values and make sure that we get the right y value just to make sure that we're right. So over here, we can check and say, okay, what happens when I plug in 2? So we get 1/4 times 8 squared. So 8 squared is 64. 64 times a fourth, that is 16. So, again, and you can grab your calculator, check them out, make sure that it works. And this one does. So we feel pretty good. And, you can check a couple of them if you want. But again, that y-intercept, where that's coming from, is that's coming from putting in 0 for x, and that we get that our y value is going to be a. And then we need to figure out, again, for the base, how our y values are increasing. Are they getting multiplied by a number? And then if we are getting multiplied by a number as we go and increase, then our base is going to be bigger than 1. If they're getting smaller, like in this one up here, that they're decreasing every time, that means they're getting divided by a number or multiplied by a fraction that's less than 1.